could I have you introduce yourself for us?
Absolutely. Yeah, my name's Eric Folmar. I guess a lot of people watching this video probably know my dad. Um, I am a student with the European Wind Energy Master Program, which is kind of a double degree program split between the Technical University of Denmark and the Technical University of Delft in Holland. I'm studying uh, wind energy engineering, specifically rotor design, structures, and composites. I graduated from Penn State last year with a degree in mechanical engineering and kind of specializing further into just the structural aspects of the design, specifically of wind turbine blades. So.
I'm here for it. I'm going to learn some things. I'm looking forward to it here. Thank you. I'll go ahead and right into my first official question that I wrote down. You've spent 2 summers working in the energy industry. The energy industry is huge. It's ever changing, very dynamic. I'm most familiar with a lot of the nuclear energy, kind of like I was just talking to you about before here. I also know I just had my kids do a whole project on radioactive disasters, looking at some stuff with some of the famous ones, some of the less famous ones. On a lot of days from here, you can see the steam from cooling towers, depending on which direction you're looking toward, whether it's Limerick or Salem. Like we're in a region for that. I don't know that much about innovations in wind energy. Can you tell us a bit about how that field is currently changing?
Yeah, for sure. As some background, in the summer of 2021, I interned for Enersys, focusing on energy storage, battery technologies. And then the summer of 22, I interned with Exelon or Constellation. They spun off their generation company, but doing mechanical engineering work for nuclear facilities. Nuclear energy is a field, especially in the US, that sadly has been very static. Most of the work I was doing was just really just a lot of maintenance stuff in terms of pipes degrading and things like that. So the wind energy industry is a lot more exciting, and there's a lot of potential for growth. When I first kind of got into wind, it kind of seemed like something that's not that complicated. You've basically got, a turbine that wind blows and it spins and you have power. It seems rather straightforward, and it is, but there's a lot of room for innovation. The big thing that's happening now, the big trend is the move from onshore to offshore. Currently, onshore turbines are actually some of the most cost-effective forms of energy production already, but that's not the case yet for offshore. But the advantage of offshore is number one, you've got much more consistent wind um, coming in, which helps to smooth out some of the transient power that's being produced. Um, More wind in general, and you can have bigger turbines. There's less obstructions because basically, when you're on land, you have to deal with things like hills and mountains and trees that block the wind flow. Whereas offshore, it's a completely flat surface. So a lot of the innovations there are relating to number one, the foundational pieces. You have to be able to install these turbines in ever increasing depths as you try to expand the reach of where you can install these. So there's a lot of technology going into the monopiles, jacket structures, and even floating wind turbines, which is the maybe the most like cutting edge thing when in that realm, trying to have floating things so you can put them in super deep water, really extend the potential locations you can install. Then also, I will say just trying to increase the size of wind turbines is always kind of an overarching goal of wind turbine companies, manufacturers, because if you have a bigger turbine, a bigger swept area, you can produce more power. Interestingly, when you scale up wind turbines, you're also you're increasing the weight, you're increasing the moments on the blades, you're increasing like the centripetal force at the rotor hub. A lot of those problems are actually kind of solved themselves as you make the blades bigger. You're also increasing their structural strength. The one issue that doesn't scale well is actually just the weight of the blades, since weight scales with volume and the strength is really just scaling with the cross-sectional area. So a lot of it comes down to trying to make these blades as light as possible while also still having the requisite structural stability, which involves, uh, materials, new and advanced composite materials that they're using, and also just, the design itself of how the internal like box beam structure is designed. I don't know, I could keep going here, but I feel like I don't want to
No,
ramble.
that's helpful, and it's also going to be good. You see my questions I'm going to ask you because I was going to get to more about some stuff with size. We'll get there later on, and even materials. I want to talk with you about materials later on. So this is excellent. I think that's the area, and I didn't know that offshore stuff was such an area of innovation. It's almost like you're saying the floating one. It's not quite the holy grail, but it would save infrastructure wise on and allow open up so many areas for where you could potentially put some of these. Do we have any? This might be an obvious question. Do we have any large scale offshore? Do we call them wind farms?
Yeah, we do call them wind farms, and yeah, there's a lot going on in the North Sea in Europe, off the coast of Denmark and the UK and the Netherlands. Um, and the North Sea is great because it's shallow, so you can just install
Mm,
these wind turbines with a massive monopile foundation. Um, in the United States, they're currently working on a project off the coast of Martha's Vineyard in Massachusetts, which is the first offshore project in the U.S. And there's some more that are being discussed that are in the works because the east coast of the United States is also fairly shallow because there's a good region out into the ocean before the continental shelf dips off. So that's actually a really exciting like
mm.
area for installation of offshore facilities. It's just kind of waiting for the funding and the
Yeah.
politics to catch up.
How far offshore are they hypothetically looking for US? Like within a mile or two, or 5 to 10 miles? Or, I mean,
Um,
we could do a good physics problem trying to figure out how far based on the height of it before it doesn't obstruct the sight line of people looking out. But I don't know if they care about that.
right, yeah, the site it's definitely a factor is the views and stuff because obviously you've got tourism industries in places like Martha's Vineyard especially. Um, I don't have an exact number for the distance that they're putting them, but it's mostly, I mean, yeah, the only main issue with having very close to shore is ruining people's views. So you can really put them wherever, depending on where the wind resource is the best. And they
Okay.
have like extensive maps and surveys that have been done where you can look at the average wind speed at a certain location, the variation in the wind speed, things like that.
How far offshore are the ones in the North Sea? I didn't even know about those.
Again, I don't have the exact numbers, but they can be pretty far off there. Like you're not going to see them anywhere on land, or they can
Okay.
be right off the coast. Like so in Copenhagen, where I was last semester, you can see like a lot of wind turbines right off the coast of the city, like in the
Okay.
water, which are kind of some of the earlier ones, because Denmark has been really a pioneer in the wind energy field. Um, there's some massive ones off the coast of the UK, and they'll have actually it's a similar structure as like an oil rig in that you have a massive platform out in the ocean that'll hold like the substation, like transformers and things, and you'll have like all these wind turbines feed into this substation, which will then run via undersea cable to a onshore substation. So you can kind of put them wherever.
Cool. I'm with you for this. This is great. I'm enjoying this. I'll go right on my second official one here. I've driven through so many wind farms across our country. There's a couple, and I know even where you guys go in Central PA, depending on what route you go to, you can see some up on the hills there. They're like one or two here or there. Maybe you can see five or six. Uh, so what determines whether you're going to have a location where you're having maybe 1 to 5, maybe somewhat bigger ones versus I've driven so much. I'm thinking of a couple areas in California where there've truly been 200. I can see it from one point. And sometimes the diameter, the region they're covering is no more than like 15 to 20 feet across, but you just have them going up the hill and a whole array of them. How do they decide whether it's going to be like what economics are going into, or I don't know what if it's politics, whether you're choosing 1 to 5, 20 to 200, what makes the decisions?
Well, again, the biggest thing is the wind energy resource. So with onshore turbines, a lot of the times, like in central Pennsylvania, you'll see them along mountain ridges, kind of in a line, because that's generally the best spots on land, unless that or like really flat plains. So in central Pennsylvania, yeah, they'll basically just fit them in. Well, obviously, you have to get land rights. You have to there's a lot more issues with actually transporting the blades and installing them onshore because you have to like work around where there's roads and where you can build roads to install them. And yeah, it's a lot more variable onshore just because of the variety of geographical features. Um, and although, I mean, they'll still be, I'm trying to think of what the biggest onshore turbines are in size, but probably a lot bigger than 15 to 20 feet. They look a lot smaller from far away. Um, for reference, the offshore ones are obviously bigger, but the largest offshore turbine that's currently installed anywhere is currently being tested in northwestern Denmark. I had the opportunity to visit it a couple months ago. Is the diameter of the swept area of the blades is more than 200 meters.
Wow. So the would that put the diameter is 200 meters. So like the what do you call the central feature of it? The tower.
Yeah, so you have the tower, the nacelle is the bit right in the center. It's
So the
called the
cell is going
nacelle.
to be a solid 100 meters or so off the ground. More
More
than
than
that? Like
150. Yeah.
wow, that's cool.
It's pretty fascinating, and offshore you can build much bigger. The largest offshore wind turbine in the world, I just looked this up here,
Yeah, yeah.
but it has, um, let's see, it's 89 kilometers off the coast of England. It has an overall capacity of 1.3 gigawatts,
Whoa.
and that's gonna be, where's the number of wind turbines here? Thought that would have been like the first thing. Oh well, but it's hundreds of wind turbines. And they're yeah, so offshore they can get pretty massive. Um, so
1.3 gigawatts. That'll just cover Back to the Future DeLorean. It needs 1.21 gigawatts. So you're 1.3. We're covered with that. Excellent. So you mentioned that the biggest size there. Do you know how small they get? Like, because I really do think that the ones I saw, I thought I saw something as small as like 15 to 20 feet. Are you
well,
saying that you don't think they get that small, or
they as far as commercial ones go, I don't think, don't quote me on this, but I don't think that there's any commercial operators that are using ones that small
okay?
anymore. They've grown. Like if maybe you're looking at an older turbine because they've they've been like every year they're getting bigger and bigger. Um, However, small wind turbines are absolutely a thing, especially for a lot of private, like just like someone might put solar panels on their roof. A lot of
Right.
people will, especially in rural areas or like farmers who have a lot of land, will install like farmer or smaller turbines to power their homes, their businesses, whatever. And that's actually to me a really cool area of research. There's a lot of differences in design. Um, like I know I saw in one of your questions about the number of blades of wind turbines.
Mm-hmm.
Um, which well, I guess I'll just kind of get into that a little bit.
Sure, go
So,
for it.
um, with a wind turbine, you're only physically theoretically able to extract about 60% of the energy from the wind that's passing through that swept area. That's called the Betz limit, and yeah, it's about 60%. With larger scale turbines, three blades ends up being about, or at least for larger scale horizontal axis turbines, three blades ends up being like the most efficient because you need to extract enough power to get the thing spinning, but you also need to let air pass. Because if you're blocking all the air, then there can be no wind and there can be no power. So it's an interesting mathematical problem to come up with that limit. And basically, manufacturers are trying to get as close to that 60% as possible. Um, but anyway, with smaller turbines, you can actually have uh, designs with two blades that can end up being more efficient in some cases because uh, you'll have them spinning faster. You'll have a higher tip speed ratio. The tip speed ratio is the um, ratio of the speed of your tip versus the wind coming in. Pretty
Mm,
sure. Again, I'm not an aerodynamic specialist
no
here,
problem.
but so you can have different designs. There's also vertical axis wind turbines. I don't know if you remember in Lincoln Financial Field, they used to have those fins spinning on the roof that they ended up
Yeah.
taking down. But yeah, those are another interesting area for a lot of innovation. There's a lot of different designs for those. They're nice because you don't have to uh, like yaw them around in order to face the wind because the wind can, as long as the wind's coming in horizontally, it
Yeah.
works. And they take up less space. You can install them in a lot of spots. So anyway, long answer to the question, which I think was, are there smaller wind turbines? But yes, there are smaller wind turbines.
It could have been private ones that I might have been seeing because especially if I'm thinking of some areas that were near LA, and it could have
Hmm.
been like somebody owns this hillside and threw a bunch of wind turbines on it, and it wasn't some big corporation for it. It was just little guy taking that, but that makes sense. And you mentioned that we sometimes have as few as two blades. What's the most you've encountered as far as I know? Three's kind of standard. Is that safe to say? Three's
Yeah,
kind of standard.
definitely.
Two is sometimes there. Have you seen five?
I've never seen, I don't think I've ever seen 4 and 5 in operation for,
Not commercial.
electricity production. I mean, if you look at like the really old Dutch windmills, I think they generally had um, 4 blades. But I mean, I think they exist. And again, and I'm trying to think in like, yeah, actually, some of the smaller ones, kind of the older style that
Hmm.
like they almost look like kind of like slanted sheets of metal. Those will have a bunch more, almost looking like kind of like a fan blade. Um, but yeah, or for vertical axis turbines, like I say, there's a whole bunch of different designs.
Cool. Excellent. I'm going to rate on the fourth one that I had here. I was reading that last year, 2020. Well, I wrote this actually end of 2022, but so in 2021, about 8,000 wind turbine blades were pulled down, and the majority of those were landfilled. And I've heard this in different places, not just last year. How much effort that you're aware of is there into designing eco-friendly wind turbine components? I know you're talking about the materials, the composites, trying to make it efficient that way. And also, like, what do you I've got my answers for this myself, but you're more into this field than I already am. I'm just curious, what do you say to people who are concerned about the waste produced by aging wind turbines?
Well, no, it's definitely an issue that a lot of people are working hard to solve. When you have composite materials, which provide a unique strength to weight ratio, it makes you almost have to use them to build these blades or they'd fail. The issue is like a composite material is a bunch of fibers embedded in a matrix of some sort of polymer. So when you've got this blending of materials, it makes it very hard to recycle because it's not a homogeneous material. Um, in addition to that, they actually use balsa wood for a lot of the internal structure because it's so light.
Yeah.
There's a big effort to try to synthesize a synthetic material that has the same properties because they'll basically put balsa wood and sandwich it with composite layers so it has the strength of the composites but is lighter because the a lot of the volume is taken up by the balsa. That's another problem because that you can't recycle that and it's also only grows in certain environments. So yeah, there's a lot of effort being put into trying to make them more recyclable. Um, as far as like people who use that as an argument against like wind energy as a whole, I think is rather narrow-minded. Just because the alternatives are so much worse. Um, and quite frankly, like the amount of material it takes to build a wind turbine is pretty small relative to the amount of material to build a power plant and all the concrete and all the emissions and waste that comes with concrete. But yeah, no, it's definitely a problem that people are working to solve is the short answer.
That's awesome. And I'd be curious to see the full stats related because that's an isolated statistic that's probably there to try an argument point. But it's still, I thought you'd have a good answer for it, and you did. But I'm curious of those 8,000 turbine blades, like out of how many operational turbines do we have that we're saying 8,000 blades in a given year are end up being landfilled? How much of space of a landfill is that taking up? And I'm not looking for these answers, but I think that if you want the full context of that snippet, you need to know big picture. What kind of area are we talking about? What kind of volume? And compare it to any other energy format. What's our waste that we're getting from coal in multiple ways that we can talk about that waste? What's our waste that we're getting from this form of nuclear? Like, it'd be interesting to have a fair comparison, which
Mhm.
this isolated statement is not a fair comparison. And
Right.
yet, those are still things that you or I could encounter and every day. Just those little isolated statements that you have to be ready to go at with. In a similar way, kind of keeping it isolated. I'm sure you've talked about it, or at least people have approached you with it. What do you say to somebody that wants to talk about bird deaths?
I have there's a graph I really like.
Okay.
I don't have it with me, but I'll just try to visually represent it. So death, like deaths of birds from wind turbines, like here. Deaths of birds from cars, like here. deaths of birds from cats. I mean, I don't think anybody's saying we shouldn't have cats. So
Right.
that's
That's excellent. I don't think I've seen that one. I'll be curious to see if I can find that. That sounds great. Very good. Thank you.
well, and obviously not to mention the number of birds that die as a result of pollution and climate change,
Yeah.
obviously. So yeah, that's my answer to that.
Very good. Excellent. Thank you. My last, oh no, sorry, I got two official ones, but my last sciencey one here. You've interned with a nuclear power plant. Nuclear power plants are essentially a large scale and complicated, kind of complicated way of getting energy from converting water into steam, then having the steam do work. Basically, a real fancy steam engine in a way. What happens inside of a wind turbine to convert the moving blades, a mechanical energy, into a type of energy that can be used by the grid?
Right. So uh, there's a lot of similarities between wind turbines and airplanes.
Okay.
Um, Essentially, each wind turbine blade is structured with an airfoil in much the same way as an airplane wing. And uh, you're basically using the lift force to create energy. So just like an airplane wing, you're going to have lift and drag along, the direction of this airfoil. The lift is created primarily by like the pressure differential that'll be created with the wind flowing over the top versus the bottom, and you'll have a low pressure region in the top, a force from low pressure to high pressure, same way airplanes fly. So there's some really cool tools that you can use to visualize this, but you'll you'll basically have your lift force and your drag force, which then you can take those vectors and convert them relative to the rotor plane that the blades are spinning in to um excuse me, to a normal force and a tangential force.
Mm-hmm.
So you'll have your tangential force along, the in the direction of the rotation plus the normal force for each blade. You basically have to like integrate these forces along the length of the blade, and eventually you convert it into your power and your thrust. So the tangential force is what's providing your power, your mechanical power, which is keeping the thing rotating. And
Right.
then you've got a thrust force, which basically just has to be absorbed by the tower and also, has to be accounted for so that the blades don't actually strike the tower.
Mm-hmm.
Um, but essentially that, yeah, they're basically just airplane wings.
But what
Uh,
happens inside of the like
all right.
what? So like, let's go Dutch. You mentioned the Dutch. Go old school windmills. Can we call the old ones windmills? Is that okay?
Yeah,
So
because
old
they're
school
milling grain.
windmills, they're turning a big gear effectively, and you can do work with that turning gear. That's not what's going on anymore. So like after you get that rotation, you have the rotor spinning, you have all that up top. What's actually going on that converts it? Because I don't think there's any. Uh, I was truly my mind was blown yesterday. I'm talking to the Lawrence Livermore guy, and I'm like, so you guys aren't doing what the nuclear guys are doing. You're not just going to convert water into steam. And he's like, actually, that's our plan. That's what we're going to do. We're going to have the energy of the sun, and we're going to make steam from that energy of the sun. And I did not they aren't doing it yet, but I didn't realize that's their end goal is, yeah, we're going to make steam too.
Yeah.
But you guys aren't making steam.
Right. No, yeah, because with nuclear, anything that's creating heat, generally they're gonna just boil water, make steam, use steam, spin a turbine. But once you have the turbine spinning, whether it's a wind turbine or a steam turbine,
Mm-hmm.
it's pretty similar. Well, you have a generator. There's definitely differences in the types of generators and even within the wind energy industry. Um, you can have some older designs, and they're kind of starting to move away from, not everybody's moving away from this, but so you can have a gearbox in there. So basically, depending on the wind speed, depending on the mechanical power coming in, you'll try to pick the optimal gear to get your generator spinning. You'll have, magnets moving around coils, and you can, um, there's different types of generators. There's permanent magnet generators, and
Mm-hmm.
there's I forgot the exact like synchronous or asynchronous. There's a bunch of different things, but either you can have permanent generator or magnets, or you can have basically coils that are acting as electromagnets being excited buy either an external auxiliary generator or they have self-excited ones. But anyway, essentially, yeah, it's a generator. And then newer technologies are using direct drive, which are mostly used with permanent magnet generators, where you basically have coils rotating in like an outer circle around an inner ring of magnets, or vice versa, um, using that magnetic flux to generate power, AC power. You can also there's a type of generator that I actually worked on for my honors thesis last year called Axio. So the this is I'm nerding out here. So
This is good.
the most commonly used ones, it's called radial flux, where you have that ring of coils around a central ring of magnets, and it's kind of going like this. So it's called radial because the flux is along the radial direction. You can also have axial flux, which is basically you've got a disk of coils, a disk of magnets, and then another disk of coils or something like that, or like little pancakes stacked next to each other, and they'll like spin along like this. So one of them will be static, called the stator. The other one rotates, called the rotor. Um, and those are cool because those are actually really useful for small scale wind turbine applications because they, with a radial flux generator, it takes a lot of torque to get it moving initially because it has certain spots along the rotation where it's stable because of the forces of those permanent magnets. So you have to kind of get over all these humps until it gets spinning fast enough where they kind of even out. With an axial flux, you don't really have that. It's kind of stable anywhere. So it's really useful for turbines that are producing a small amount of mechanical power or in lower wind speed conditions. And it kind of offers a lot more flexibility. Um, so anyway, there's
So if my
different ways to do
students
it, but
were
it's
trying
it's
to,
generators.
no, you're good. This is excellent. I'm with you fully on this. This is very good. They're very helpful. Um, so if they were trying to draw a comparison for a lot of my students, maybe for their parents, their cars, the restorative braking, getting some energy back to put into a battery ends up being a very similar conversion of mechanical into electrical energy as what you guys are doing, taking the big scale uh, spinning turbine, putting it into a usable energy. Is that fair to say?
Yeah,
Okay. Um,
absolutely.
and a special to you follow up with this because I mean your internship last year versus your internship well, the year before effectively. Um, I know that some of the early stuff with wind was you can't always benefit from all the biggest storms. Like there's a limit to how much you can store. And you said you were just working almost in battery capacity, battery stuff there. Uh, would you say there's been advances in have some of the I know there have been have some of the advances in energy storage been pretty influential for wind to allow for heavy winds and be able to handle the mismatch of supply and demand between when there is a lot of wind, when there isn't?
So there's kind of two parts to that when it comes to storms. Um, Number one, just mechanically, if your wind speed gets too well, all right. Number one, um, every turbine is going to have a rated wind speed. At this wind speed, this is the point where it's designed to operate. It's going to produce the power that it has on the label. So if you have a 14 gigawatt offshore turbine and it's the wind's blowing, say, greater than 11 meters per second, you're going to be operating at 14 gigawatts. Any higher than that, you're not going to increase your power because the blades are actually going to pitch to actually make them a little bit less efficient just so it can stay within the tolerances of the machine itself. Um, if you get too high, you'll actually have to shut down the turbine just for safety reasons.
Right.
But the bigger issue, the bigger overarching issue, like you were saying, is the issue of the transient nature of the power. You can't predict the wind, or if you can predict it, you can't control it. Um, so you're gonna have these, certain times when there's being a lot of power being produced, and sometimes where there's not a lot of power being produced, and that doesn't always line up with, usually doesn't line up with demand. And there are a couple ways that you can solve this. Um, One way is actually just increasing the capacity and interconnectivity of your electric grid, kind of like the law of large numbers. If you have a bunch of turbines, like say all across Europe, and all the grids are connected to each other, if you have a bad day in Spain but a good day in the UK, you can send power from one place to another, and that inherently evens out these transients. But yeah, obviously the other big one is energy storage. So there's a lot of work being done into this. My internship a couple years back, we were focused on lithium ion, which is you know the biggest battery technology that's coming out. It's easily rechargeable. Issues with that are number one, it's uses a lot of rare minerals and stuff that are pretty intensive to mine and kind of scarce. They they degrade over time. They become less efficient. Their capacity goes down. Um, Things like that. So there are other ways to store energy besides batteries. One that's been used for quite some time is actually hydro pumped storage. There's some facilities that will literally just pump water up into a reservoir that's higher up, and you're just storing it as gravitational potential energy, and you can let it come down and turn it back into electricity via um, water turbines
Yeah.
when you need it. And the big one that I was actually working on last summer with Constellation is hydrogen. There's a lot of potential for hydrogen to be kind of used as an energy currency and energy storage means. Um, Essentially, if you have a lot of energy, you can make hydrogen by splitting water molecules via electrolysis. So you just basically put in electricity and water, and you get hydrogen and oxygen.
Huh.
So you can store the hydrogen, um, and then you can either combust it, or you can use a hydrogen fuel cell, which is basically just electrolysis backwards, um, in order to turn that back into electricity at a later time. They're actually talking about for some of these very large offshore wind farms, building, like I was mentioning earlier, those offshore substations they have.
Mhm.
They've been talking about actually putting electrolyzers on those platforms in order to store excess energy right there as hydrogen, and then they can transport it out. So that's a big thing that a lot of work's being done into, and that's also good because it can replace um, a lot of like instead of using the hydrogen to make electricity, you need hydrogen for a lot of things, uh, and most of the ways that people make hydrogen now involve fossil fuels. Um, So yeah, you can use hydrogen for things like sustainable aviation fuel, which is very hard to decarbonize, and other things like that. So there's a lot of work being done with hydrogen.
Awesome. Very, very cool. Thank you. I don't know if you'll have an answer to this one. You made me think of it there. It's honestly a bit more potentially politics. So feel free to just say pass, I don't got it. But based on what you were saying there, talking about sharing energy within the kind of European grid. One country needs it, they might be able to get it from another country. My rough understanding, no expertise in this whatsoever. My rough understanding is that here our states are not nearly as friendly, like Texas, like somebody else. When they have an energy problem, do you know if our large grid is as how the two compare? Is Europe almost more generous with their working amongst each other than we are in our various states, or are you able to comment on that?
Yeah, I am.
Oh, sorry, we got our school bell. There you go. Go ahead.
Interesting that you mentioned Texas, because that is actually a very specific problem to Texas.
Yeah,
Um, I would say that there's two primary United States grids. There's the Eastern interconnection and the Western interconnection,
and
and
Texas.
and Texas.
Sorry.
So yeah, so within those grids, there's a lot of cooperation. Yeah, I mean
Okay.
there power crosses state lines all the time, um, and there's certain like even smaller regional organizations that regulate this, but yeah, in general, like powers crossing state lines all the time within these grids. Texas decided that they didn't want to be subject to federal regulations, so by keeping their grid just within the state, they were not within the purview of the federal government, which for a while allowed them to have, I think, a little bit lower energy prices. They also have a lot of wind energy in Texas, but obviously, as we saw last winter, that came with some drawbacks as their entire system failed and uh, they weren't able to solve it or like get any assistance because there were no interconnections to other grids. Like El Paso, Texas is on the Western interconnection and they were
Huh.
fine. But but anyway, yeah, there is a lot of cooperation, but there does need to be a lot of investment in transmission within the United States. Um, Either building some bridges between the East and West to increase the flow between the two, and also just because of the inherent fact that in general, with something like wind energy, a lot of the biggest potential for wind energy is located in areas where there's not a lot of population. So you
Right.
need to transmit the energy from the turbines to the people. Um, Also, as we, strive to decarbonize society in general, that's going to greatly ramp up demand for electricity, which also means more transition or transmission needs. So yeah, transmission is a huge thing that we need to invest in to actually meet a lot of these climate goals people are setting, because you can't just build the wind turbines or the solar panels. There's a lot more that goes into it that doesn't necessarily get as much publicity.
Yeah. Wonderful. Excellent. My last thing actually comes as a question courtesy of my wife. Courtesy of my wife. She heard I was going to be talking to you. She was excited to hear I was going to be talking to you, and she wanted to make sure I asked you this one here. So, courtesy of my wife here, my final question doesn't need to be physics. I was curious, do you have anything else? You're in Chester County right now. You'll be going back to Denmark. When are you going back to Denmark?
February 6th.
February 6th. But you are a Chester County High School grad. What advice would you give in general to if you want a current Chester County High School senior? What should they know? You were not that many years ago in pretty close to their shoes. What would you want somebody here to know?
Um, Honestly, like, well, all right. So I went to Unionville. Sorry. Um,
Secrets out.
but no, I mean, obviously my dad teaches at Kennett. I think that it's I don't know. I mean, I think that the students at Unionville or Kennett or a lot of the schools in this area are just really fortunate. Um, I know when I went to college, I felt super well prepared. Um, and I felt like I had a leg up on a lot of my classmates. I don't know if that's advice, but just um, just appreciate that. Um, Try to, I don't know, who am I talking to? Seniors. So um, I'm bad at this. I feel like just try to follow your interest. I've known a lot of people my freshman year of college who came into college going with with a certain degree plan and ended up changing it throughout the course of the year. My one of my best friends, Harry, started out pre-med and ended up quadrupling major in a bunch of liberal arts things that had nothing to do with STEM at all, which great for him. Now he's getting his PhD in philosophy. But like don't think, that if you don't have everything figured out, like going into college, like that's totally fine. Um, and there's a lot of room to switch it up and to change your mind. And you shouldn't feel that that's a bad thing. Um, because the earlier you figure that out and you make that change and you like it, then the easier it's going to be, the happier you're going to be probably. Um, so that's some general advice. I don't know.
No, that's good
AP
advice.
classes are great because I was able to get to skip a lot of weed out classes and classes that may not have been incredibly interesting. And I was also able to have enough time to study abroad just by taking AP classes in high school. So that was huge. I
No, I
don't
think
know.
that's really good advice. I was just reading a book truly in the last 24 hours where although it's a fantasy novel, the author was almost joking like that one of the most heroic things you can do is reevaluate, not just stick with your original plan and say to yourself, "Hey,
Absolutely.
maybe I should actually think about this thing that I thought was a good idea a year or two ago. Is that still a good idea because I've learned more along the way?" And that's valuable. That's a really valuable thing for
Yeah.
people to have going into college to actually stop and reevaluate what their original plan was. I like it. I think that's a good piece of advice there. Thank you, Eric.
Absolutely.
It's been excellent. I truly did learn a lot. You were very helpful for this, and I think my students will be able to learn some stuff there.
Oh,
So I appreciate your time. Go ahead.
yeah, no, I was just gonna say thanks for having me on. An honor to be sharing the spotlight with an Apollo 13 astronaut. So, um, but yeah, I definitely hope this is useful and interesting. So, yeah, it was fun to talk.
Thank you. Appreciate it. I'm gonna hit stop recording.